What's up, y'all? And today we're gonna balance chemical reactions. This is part 2, and this is a second question problem. So, this is another hydrocarbon being reacted with oxygen gas to produce carbon dioxide and water. Like I said before from the previous video, this is an example of a combustion reaction because you have a hydrocarbon being burnt in the presence of oxygen to release carbon dioxide and water. So this hydrocarbon specifically is a 2-carbon compound, and this is ethane. It's an alkane. So I'll get back to that in an organic chemistry video coming later this month, hopefully. And this ethane is reacting with oxygen, but let's count the individual atoms in each of the reactant species. As explained in the previous video, you have to make sure that the number of atoms on the reactant side, which is this side, is equal to the number of reactants on the product side, right? So there are 2 carbons here, but there's only 1 carbon here. We'll get back to that. There's 6 hydrogen carbons here. There are 6 hydrogen atoms here, and there are only 2 hydrogen atoms there. There's 2 oxygen atoms on the reactant side, and there are actually 3 oxygen atoms on the product side, because 2 plus 1, this is 1, but we don't really write the 1. It's silent in chemistry. 2 plus 1 is 3. So there are 3 oxygen atoms on this side, but there are 2 oxygen atoms on the other side, which means that this is not balanced. This is an unbalanced reaction. But the problem here, the goal for today, is to learn how to balance an ethane combustion reaction. So what I would do is let's look at the hydrogens. Why don't we start off with the hydrogens, right? No, I'm sorry, carbons. I mean, it depends. Sometimes it depends on what you take, because the species contain multiple atoms, and by placing different multiple coefficients, it might disconfigure the reaction in a way. Like, if that doesn't make sense, I'll get back to that. So let's start off with the carbons. We have 2 carbons here. In order to get 2 carbons on this side, put a 2 right in front. The 2 affects the carbon, and it also affects the oxygen. So now there are 2 carbons here, and there are 4 oxygens here, because what? 2 times 2 is 4, right? So the carbons are balanced. So let's take a look at what we can do for the hydrogens. There's 6 hydrogens here, put a 3 here, and the hydrogens are balanced. As simple as that, right? So 6 and 6 is equal on both sides. Yeah, so that's the hydrogens are balanced, the carbons are balanced. That's good. Remaining the oxygens. So the oxygens, there's 2 oxygens here, and there's 4 oxygens on this species, but there are 3 oxygens in this species. So 4 plus 3 is 7, right? So if 4 plus 3 is 7, so that means there's a total of 7 oxygen atoms here, but there's only 2 here. So what can we do? Well, there's 2 ways of doing this actually. You can put 7 onto here, because the same way that you can multiply this coefficient to get a new number, you can the same way you can multiply 2 times 2 to get 4 oxygen atoms for this product. You can do the same here. You can multiply 7 on 2 by 2, and what does that give you? That gives you 7, because the 2's cancel out to give you 7, if that makes sense. Oh, excuse me, I think the camera's a bit blurry. I hope that makes sense. 2 cancels 2 to give you 7, and there are 7 oxygens on this side. So carbons are balanced. There's 2 carbons on this side, 2 carbons on this side. Hydrogen, 6 hydrogens on this side, 6 hydrogens on this side, and oxygen. 7 oxygens on this side, 7 oxygens on that side. Everything is balanced. Life is good. I got that from a professor. So yeah, this reaction is balanced. Hope this was helpful. Like and subscribe.